Okay, so let's take a look at an example of an equation that we could solve algebraically using some of the log properties that we just looked at. So a bank account earns 6% annual interest compounded annually. The balance B of the account after T years is given by the equation B is equal to B sub 0 times 1.06 to the T power. Now we know what that really means. That 1.06 means is that this thing has been growing. It's growing over this time period at a rate of 6%. That the 1 means I have 100% of my original deposit plus 6%. So that B sub 0 means my initial deposit that I'm going to make. And we want to know if the account starts with $250, we want to know how long will it take to triple the balance of the account. So taking a look at what the equation that would result, the original investment of B sub 0 is $250. It's being multiplied by 1.06 to the T power. So like this right here is the growth factor, and T represents how many years that happens for, and we want to know what it triples. Well, if you triple $250, you would get $750. Now, how we have done this in prior lessons is we would maybe have designated this as Y2 and this as Y1, and we would calculate the intersection of the two graphs. And you know, that would be a graphic way, and I think that is a way of checking our answers, but I feel like you know, this is an algebra class, so we should be doing them algebraic methods, and so here's how we can use log properties to solve something like this. So step one is we're going to go ahead and try to get the growth factor all by itself. So since this is the growth factor, we want to get this all alone, and so we want to get rid of this 250. Well, it's being multiplied by that, so we divide. So dividing both sides by 250, I'm sure it makes sense that this is equal to 3. And that's because we wanted to know when the amount was tripled. So what we want to know is when the growth factor 1.06 to the T power is equal to 3. So then how do we solve that? So the variable is in the position of the exponent. So how does that work? Well, how that works, how we can get the variable out of that position of the exponent, is we can simply take the log of both sides. So just like you can divide both sides by the same thing, you can raise both sides to the same power, you can take the square root of both sides, you can subtract the same thing from both sides. Well, you can take the log of both sides. Now, why would we ever want to do that? Because, you know, that kind of makes it look a little more complicated than it was to begin with. But logarithms have this great property we just learned about. That's the power property of logarithms that allows us to take the power, which is the t, and that's the unknown here, and bring it down in front and turn this into multiplication, so that this would be t times the log of 1.06 is equal to the log of 3. Now, if we wanted to solve for t, now we've turned this into multiplication, so we can easily undo multiplying with dividing, and we can just simply divide both sides by the log of 1.06 and type that right in our calculator, because of course this is log base 10 that we're using, and so the log of 3 divided by the log of 1.06 turns out to be approximately 18.854, so about 18.85 years for the money to triple at that interest rate. So again, all we really needed to do in order to get that exponent, that variable that's in the position of the exponent, out of that position is to simply take the log of both sides. And since we can choose any base that we want when we take the log of both sides, we of course used base 10 because of course that is one of the ones we have that nice dedicated key in the calculator for. And then now that we've turned that into multiplication, we can undo by dividing.